I just have a question, like, when I was working on the homework, that we were working on, I came across it, when it talks about net force, and it gave me like, did like a diagram, a free body diagram. Sorry, I can't remember, a free body diagram, and it told you to find the net force, and we did like on a bunch of them, but there's some I was confused on, like,
I know that there was some that had like all the forces acting on it, and it said to find the net force. Then there's some that were like, you have two forces, and then it would show you what the net force would look like. So it'd be like this. And it would say find the third force. Is that kind of what you're talking about?
oh, just find the third force.
Yeah, so like, you'd have these two forces, and the third force, they would end up equaling the net force.
Oh, okay,
So I don't know if that's kind of what you're seeing.
that's probably what it is.
Yeah, because like, the ones like this are pretty straightforward. You break them all down into components, and you find your net force. Like, this one would end up being something like that. No, it wouldn't be like that. It'd be like this. But this one is like, you have these two forces and then the net force, and you have to find out what is causing that net force. And it'd probably be something like this. So you'd have a third force that was causing that, along with these two.
Yeah, that was confusing to me, just like finding that third force.
Yeah, so then what you do, let's do an example of it, I guess. So if this, say this was like 2j, and this is negative 2I minus j, and then your net force was like I plus j. So basically you're trying to find the third force. It's like some force 3, whatever it would be, that would cause that. So what you can do, it's like on the first type, you do the sum of forces in x and the sum of forces in y. And then you'd set those equal to the net force x and the net force in y. So this one you do the same thing. So you'd say the sum of forces in x equals, well, you don't have any from here, but you've got negative 2 plus f3x equals the net force in x, which is 1. And then you do the same thing in y. So you'd say 2 minus 1 plus f3y equals 1. Does that make sense?
Sort of.
Yeah. Okay, so yeah, let me draw another, like what it would be normally. This is not a very good marker. So if you're just doing it normally, say you had like, this is I plus 2j. Is that okay to write the vectors like that? You know what that means?
Yeah, well, so the I just, tell me what the I and J represent.
So I is basically your x component,
Oh, okay.
and j is your y component.
Okay.
So what it actually is I, as a vector, is this vector right here. It's length 1. And then j is this vector right here. It's length 1. So if you say you have I, that means you have that one vector of length 1 plus 2j those are each equal to 1. That gives you this vector right here.
Oh,
So this basically just breaks it down into x and y components for you already.
gotcha.
So if you had like this was f1, and you had f2 was I minus 1.5j, and then 3 was something like this. It was like negative 2I minus j. So this is f2 and f3. And you wanted to find the net force. What would you do for this one?
Find the net force.
Yeah.
Um, oh,
So whenever you have a free body diagram, you start with your free body diagram, and then you want to go to like the summation of the forces. Right?
oh, okay, yeah.
So that should be your reaction anytime you draw a free body diagram. The next thing you're going to do is sum your forces in x and y. So if you sum your forces in x, that would equal f1, the x component, is 1. f2, it's 1.
1, -2. Okay.
And then sum your forces in y, so that would be
2, and negative 1.5, and negative 1.
so then what's your net force in x?
0.
Net force in y?
Negative 0.5.
So what that tells you is your net force vector would be equal to negative 0.5 j. So you could draw that just like this. You come straight here and you just do negative 0.5. So that would be your net force out there. So those are the normal ones that you did. So this one, you've got force 1, force 2, and you know there's a third force that you're trying to use to find your net force. So how did you set this one up a little differently to find force 3 instead of force net?
So you add force 1, force 2, and then minus that.
Yeah, so that works. So you do your x component is 0 for force 1, minus 2, and it'll end up being minus, but let's do this. Let's say plus f3x. Does that make sense?
So the third force.
Yeah, so just like on this one, this side, this was f1 plus f2 plus f3.
Yeah.
Same thing here. Those are the y's. These are the x's. So this time we don't know the third x, but then we do know that it'll all be equal to,
I plus j.
yeah, so for the x will be 1. That's f net x. And you do the same in y.
Yeah. So f1 0.
Well, the y component.
Oh, 2j.
Yeah.
And then negative 1. And then plus f3y equals 1.
And then you can solve for f3. So here you take this to the other side. f3 of x is 3.
Yeah.
And what's F3Y?
2. Oh, no, wait. 2 gets inside. 0.
Yeah. So then your F3 would have to be 3 in the X. So it would just be this. So that's how problems like that work. You set it up the same way. You just recognize that your sum of forces will always be like your F1 plus your F2 plus your F3 equals your F net.
Right.
And you just plug in what you already know and find the last one.